So let's imagine that we were going to compute the volume fraction of stuff that came from a modernist thickener. So you know, the amazing thing about modernist thickener is that a crazily small mass of such a thickener can lead to a huge increase of viscosity. So what can happen actually, even if you put in a crazy small amount of a polymer, is that this volume fraction that you compute can end up being larger than 1. So you could go through the calculation, and you will do this in an exercise following this video. You could go through the calculation and find out that for the amount of xanthan gum you put in, the volume fraction is larger than 1. Now that's crazy. There's no way the volume fraction can ever be larger than 1. There's no way that the volume of the polymers in the dispersed phase can be larger than the volume that you started out with in the first place. That's simply nonsensical. But it does tell us something important about what's going on. What happens when the volume fraction from our equation of the week ends up being larger than 1 is that the blobs actually overlap with each other. They're not separated by space. They overlap. And when they overlap, then what they actually do is this. They start to entangle. So instead of becoming blobs, they unfold and basically tangle up with each other like a bowl of spaghetti or something. And when that happens, it becomes even harder for the polymers to move by each other than it did when they were isolated blobs. This makes the viscosity go up even more than it would have gone up if you had thought about it differently. And this is really perhaps the critical thing about modernist thickeners, that it just turns out that even with a very, very small amount of volume fraction, a very small weight of polymer, you can get the total volume fraction to go over 1. The polymers become entangled, and then you have a really viscous sauce.